Hello and welcome to another one of D's ADD videos. Today we're going to be looking at an intermediate inverse trig integration problem. We're building up to the completing the square problems for inverse trig. But before that, what I wanted to do was see if you could handle looking at a binomial squared and interpreting that as your box squared or your u squared. So let's see if you can handle that. Again, I'm still with this student and they're still muted, so sorry about that. So before we do one, I'm just going to give you one that's already in that binomial squared form and see if you can handle that. Any ideas? Okay. Don't let it intimidate you. All we have here is a box and then the box squared minus a squared. That's an arcsecant. So what we need to do is let u equal x plus 1. du then equals what? Good. And at that point, you have the ability to substitute and then plug back in. A is going to be 2. And then plug back in what your u equals. Do you understand? Do you have any questions? So the clue was that you had this and this was the same thing squared. So that's the basic form of the, right? Okay. So now that you got that under your belt, let's look at this one. Did you write the last one down? Did I give you enough time to write it down? Are you sure? I can give you another couple seconds. You got it? All right. Let's look at negative dx. Let's see, x squared minus, what would work here? Give me 1 second. 4x, and then it's going to be minus 2 plus 4. No, that's not going to work. I need 13. All right, let's look at this problem here. So at first glance, it looks like a nightmare because you can't do u sub. You can't do it separately. There's no long division to be done, right? And then you're like, okay, well, let me try by parts. Well, that's not going to work. Well, how about partial fractions? Can we factor this denominator? Are there any factors of 13 that add up to negative 4? No, there aren't, are there? So we have to ask ourselves, well, what the heck is going on? Then you have to start thinking outside the box, okay? So here we have something that may be manipulated to give us one of the inverse trigs. So what you do is you say, okay, let me try completing the square for the denominator. And in completing the square, the first thing you have to do is make sure this coefficient is a 1, and it is. So then you take half of this term and then square it. And it goes here, and then you do the opposite right there. So let's do that. So when I plug in, I'm going to have integral of negative dx over x squared minus 4x, and then plus 13 over here, left a little space. What's half of negative 4? Squared. What happens when you square that negative 2? Plus 4. And since I just introduced a new term, go ahead. What do I do? Good. So now when I did that, I have to rewrite the problem. And this is now what is referred to as a perfect trinomial square. And that means that you can rewrite this as a binomial squared. What does that mean? Well, I can rewrite it as something squared like that, and it's always going to be the square root of this term plus or minus whatever number you took or got whenever you took half of this. So square root of x squared is x, and what was half of negative 4? Negative 2. So you put the negative 2 there, and that's rewritten. And then here, what's 13 minus 4? 9. And now it looks a lot more like an inverse trig, right? D box over box squared plus a squared. So what you can do is you can then let u equal x minus 2. Du then becomes dx. And you're going to get oops, that should be u up top. What's going on? Oh no, I'm getting dizzy. All right, so yeah, it'd be negative arctangent. So negative 1/3. What? Stop saying squared. There's no squared here. Whenever it gets over here, it's no longer squared. It's just u over 3. It's okay. I'm just trying to make a point because this is the second time you've made that mistake, so I don't want you to keep making it. So sometimes I'll just emphasize something, not because I'm angry. I just want you to be aware of it. What kind of teacher would I be if I got angry when you made a mistake? What are you doing, Johnny? Why are you crying, Johnny? That was my voice box. Was that perfectly timed? Of all the sentences to say with it, I think that was, yeah. You know what? I don't think I ever made that repair. I think I started the recording again, but I don't think I ever fixed it to where you could be heard as well. That's so funny. So there's just going to be a bunch of pauses after I speak. I'm sorry. Next time you'll be a star. Okay, do you have any questions on the completing the square one? So I hope I've further eliminated any doubts you might have. They can get even trickier than this. So practice, practice, practice. Thank you and have a nice day.